Okay, so hello ma'am. My name is Viraj Dhadas and my roll number is 4102. So today I am going to give a topic presentation on advanced cryptographic mechanisms in blockchain. So in this we will discuss about the core concepts of blockchain and the advanced cryptographic mechanisms and at last the real world impacts. So let's start. Blockchain is basically a decentralized ledger, means there is no central authority to controlling it. Whenever transaction happens, it is been broadcasted to the network. After that, nodes will verify it. After validation, it is added to a block. And once the block is added to the chain, it cannot be changed. That's why blockchain is considered as secure and immutable. Now, the question is, why do we need advanced cryptography? Blockchain promises a decentralization and trust, but security threats are increasing day by day. In the future, even quantum computers may break traditional cryptographic algorithms. So, blockchain needs a stronger and more advanced cryptographic techniques to protect privacy, improve scalability, and secure transition against attacks. Let's understand the role of cryptography. Cryptography is actually the backbone of blockchain. It ensures four things: security. No unauthorized person can access fund. Second one is integrity. Data cannot be modified once it has been stored. Third one is authenticity. It verifies the real sender. And at last, the privacy. Protects the user identity. Now, public key cryptography and digital signatures. In blockchain, every user has two keys. First is private key and second one is public key. Private key can be kept secret and the public key can be shared with everyone. As example, when someone wants to send a transaction, then it can be signed with the private key. Network verifies it with the public key. Using the ECC, elliptic curve cryptography, it is mainly used in the blockchain. Now, the digital signatures. It ensures that the authentication, non-reputation, and integrity. Next is cryptographic hash functions. Hash functions converts any input into a fixed size output. It has three main properties. First one is it is deterministic, second one is one way, and third one is it is collision resistance. As example, Bitcoin uses the SHA-256, but the Ethereum uses the KECHAK-256. Even if we change one small character in the input, the hash completely changes. That's how blockchain detects the tampering. Now, the another mechanism is zero knowledge proofs, ZKPs. ZKPs are powerful cryptographic tools. It can used like we can prove any truth without revealing its information. As an example, I can prove that I am 18 years old, like without revealing my birth date. And it is mostly used in the Zcash in the real world examples. And it is mainly used for the privacy and the security purpose for not revealing the user's privacy. Now, some advanced cryptographic techniques for privacy. The first one is homomorphic encryption. In this, computation is performed on the encrypted data, not on the decrypted data. So it means it can be useful for the useful for the first process. It don't need the decrypted data also for the performing the computations. The second one is secure multi-party computations (MPC). It enables multi-parties to jointly compute functions over their private inputs while keeping those inputs secret. Means it is mainly used is in the voting options or shared analytics. Like it can be used like uh, we can vote anyone or then it will be private for the computations. And now the ring signatures, a typical of digital signature that ensures anonymity by providing that message was signed by one member of a specified group, the ring, without revealing which member signed it. Means uh, any member of the board can sign it, but it will not reveal its identity. So it may use for the privacy purposes also. Now let's talk about some different mechanisms also. Stealth addresses and ring signatures, unlinkable transactions. First one is stealth addresses. It generates unique one-time user addresses for each transactions, making it impossible to link multiple payments to a single recipient's public address. Means it generates multiple addresses to a single participant. Means we can't locate or track a single participant with same addresses. It is useful for the mainly for the privacy purposes also. Ring signatures. It allows a transaction to be signed by any member of a predefined group without revealing which specific member performed the signing. All members of the ring are plausible signers, means thus obfuscating the true senders. Means here we can't get the information of the real signer member. Here it is mainly also used for the privacy purposes and the security purposes for not revealing the user's information. These mechanisms are notably employed by the privacy-centric cryptocurrencies like Monero to significantly enhance sender and receiver's privacy. Now, let's talk about some real-world impact and ecosystem development. First one is multi-sig adoption, means multi-signature adoption. Multi-signature wallets are widely adopted by major cryptocurrencies exchanges like DAOs also and the enterprises also for the security and the privacy purposes also and adoption purposes also. Gatekeep is in action. Zero knowledge proofs, as we discussed before, are actively powering privacy layers on platforms like Ethereum and forming the backbone of advanced decentralized identity systems. Third one is MEV mitigation. Encrypted mempools are successfully reducing maximal extractable value MEV losses, which are estimated to be in the hundreds of millions of US dollars annually, protecting users and market integrity. Open source catalyst. The development and widespread availability of open source cryptographic tools are accelerating blockchains, fostering a more secure and robust ecosystem to its adoption. And now the conclusion. As we've discussed in our topic, we can conclude that cryptography is in a blockchain's backbone. Essential mechanisms. And amongst the cryptographic mechanisms are privacy, security, and the scalability. Unlocking new use cases means future blockchains will increasingly rely on these cryptographic innovations to enable new trust minimized models. And at last, call to action. We have to invest in the blockchain for the truly secure, decentralized future. Thank you, ma'am.